I don't like standing at the podium and talking. So if you want to listen to me, you have to come front. Can you hear me in the back? Okay. So I start with a simple question. How many of you have seen a alien? Anybody? I have seen. Anybody wants to join me? No? None? Nobody. That guy is the first alien. Who's that? Neil Armstrong, the first alien. See, who's an alien? The person who is visiting from other planet or other than your hometown. So he is visiting from Earth. He is visiting where? Moon. So is he not the alien? Yeah. So next. So even now I'm just leaving it to you that you have to come front to listen to me, hear me. If I go there on the podium, you may not like the talk. Okay. So next. Many people ask me, we are seeing moon from whole of our life till the first man, okay, first man, woman were born. They are looking at the moon, and how exactly or what exactly we are going to learn more by going to moon, whatever the moon missions ISRO is launching or other nations are launching, particularly America and Japan. So what exactly we are going to learn? Why do we need moon? So all we are familiar with, my mother used to say, Chandamama Odiba, Chandadina Adiba. And whenever you are not eating, so your mother is going to show the Chandamama and say that, okay, you eat that. So other than that, what exactly the use of studying moon? You may be asking this question, why ISRO is spending crores of rupees and why Indian government is spending thousands of crores on a mission, which we can see from here. Moon. Moon exists, moon will exist, or moon may exist beyond our life. So I'm trying to answer you that question. Why do we have to study? What is the importance of moon? What is enigma behind moon? Next. So moon is always or was always fascinating. Almost all the cultures, whole world, they actually use moon in multiple of their mythology and stories and everything. So some cultures like India, moon is a man. In some cultures like in Greek and Roman, it's a woman, Selena, or Roman goddess Luna. So like that, each and every culture somehow or the other has moon. And in some cultures, moon is both man and woman. So during that rising phase, he's a man. Waning phase, it's a woman. So this next. So in this way, almost everywhere, moon comes into picture. Why? Why the people are so much interested in moon? Before even thinking of actually launching a satellite or something, why the people were interested? See, the ancient man, as soon as he stopped gathering and hunting, became an agriculturist, one of the main things he looked for is to actually predict rains, when the rain is going to come. For that, you need a calendar. So anything which has a repetitiveness, he started using as a calendar. First one is a day. So sunrise to sunset and again sun coming the next day after 24 hours, everything he started using as a basic for a day. Then came sun going around the earth, that he started using as a year. So then came moon. Moon has a particular, a special place in almost all the cultures, particularly in Indian culture, because it defines the nakshatras, whatever we call it as rain, Malay nakshatra. You can take as Bharani or Swati or Rohini. You take all the 27 plus 1 nakshatras, all of them are associated with something or the other rain. So since you can't remember, you even actually you assign certain things. If Bharani nakshatra comes, the agriculture, your produce will be a loss. You will be at loss. Dharani bandu male bharani bandu dharani tumbitu. So like that, each one you are associating with that, and the way you define a rain star or Malay nakshatra is by looking at where exactly moon is at that time. Okay, so moon gave a perfect calendar for people in the ancient stage when they did not had all our atomic clocks or watches or Apple watches and anything. So that's where our relation with moon started for the agriculture. I just want to say here, even the astronomy, actually astrology and astronomy also started exactly the same way. But after some time, astronomy stopped at actually saying when you see what you see. Or in other words, when you expect certain things, certain events to happen. It may be eclipse, lunar eclipse or solar eclipse or whatever the star at what time it rises, all these things. But when somebody started using that information to start predicting certain things, then it forked into astrology. The difference between astronomy and astrology till there was the same. Okay, after that you can see, you can actually use some knowledge, not the knowledge, data, in any way you want. So if madam asks you some question, if madam is not looking at you, the first thing you see is Google. So what does Google tell you? What does Google give you? Is it knowledge or information? Information. So that's why I actually asked the kids, maybe you also, I am old enough to call you as kids. So you also avoid using mobiles to look for answers. The main reason is, if you ask Google for something, it might give the answer, but the answer will be so specific that it will actually tell you which book to see and what page number to see and what line. So what you miss out is, you miss out on all the other knowledge corresponds to that, how you reached, how the person who gave that answer reached there. You will be missing out all those things. There's a difference between knowledge and data and information. So I'll just give an example. I was attending a workshop. So one of my faculty who is from UK, he actually told me an anecdote. In UK, in winter, it will be very cold. Yes. So at the same time, in winter, the number of deaths, particularly because of heart attack and heart failure, will also be very high. So somebody saw these two things. So you have information, you have data. So then he connected the two and he came up with a conjecture or a theory. In winter, what happens? So it is so cold that to warm, you use electricity so much that as soon as the electricity bill comes, you see that get a heart attack. So you can actually come up with a theory very easily for each and every data set. It may be true or it may not be true. How do you say which one is true and which one is not true? You will not learn that by just directly going to the answer. You have to learn how that answer is reached, how the person, whoever has done that. Hence, I request you to reduce your usage of your mobile, tab, computer, anything, and try to read books. Even today, I suggest all of you to read books, at least one. Now, earlier I used to say one per week, and later it became one per month, at least one per year. Okay, thank you. Sorry for my this one. Next. So, if you see inner solar system or whole of our solar system, moon has a very, very particular place in our solar system. The reason is, moon compared to any other planet, the ratio, if you take a planet to its moon, our moon is the largest in our entire solar system. Not in the size, but the ratio. Next. So, if you consider our moon and this one, it's almost 1/3. So, whereas our Earth is around 12,760 kilometers, our moon is very close to 3,500 kilometers in radius. But our moon is not the largest one. Ganymede is the biggest moon in the entire solar system. Okay, Ganymede is around almost double our moon. but in comparison to Jupiter, you see how small it is. So that's what I was talking about the ratio. Oh, I do have it. So that's what I was talking about the ratio. Okay, when compared to Earth, Moon is very very big, but in compared to Jupiter, its Ganymede is very very small. So what? What does size doesn't matter, right? Next. So, but this size plays a very very important role. Okay. So the first one, all of you are aware of tides. The tides on moon on Earth are mainly caused because of existence of moon. Every day you get high tide, two high tides, and two low tides. Okay. Till now I am unable to understand. Moon is here, gravity is pulling, so I can understand this tide, high tide. Can anybody explain why high tide is there on the other side? Very simple question. I do understand high tide towards moon. Why there should be a high tide opposite to moon? No, not the same time. Shall I leave that as an exam? This is homework for you. Think about it. So if by the end of the talk, if you can't make out, I'll give the answer. Okay. So next. So every per day, a person or every day, you can expect two high tides and two low tides everywhere, the whole Earth. This tide is very very important for our existence. For me to be here and talking in front of you is, if I say, because of tides. How many will you agree? So we'll see. Next. So before going to moon, one of the basic questions asked by most of us is, who are we? Where did we come from? Are we alone? Where did we come from means not human, life itself, where exactly it originated. The next question is there life anywhere other than Earth? Okay. So first question to ask is that, and many searches are undertaken. For example, you might have heard about SETI, search for extraterrestrial intelligence. So many such searches are done to look for intelligent life everywhere, which failed. So now we are not looking for intelligent life, we are looking for life itself, or at least sometimes the signatures of life, biomarkers. So we have failed completely till today. Okay. So next, on Earth, there are 8.7 million species of life as of today. This after losing out 90% of the different varieties of life. Remaining 10% itself is 8.7 millions. If you see, this is just a sample of images of moth. So many varieties are there. On Earth, we have, even after trying to destroy almost entire life other than human beings, still there is 8.7 million species on life. Okay. So if that's the case, why do you expect that only Earth is the only place where we can see life? So let's see. The answer on Earth is moon and tides. Okay. Even today we don't know how exactly life originated on Earth. But we know how the building blocks for life came into existence on Earth. Which are the building blocks of Earth, life? Building blocks? DNA and RNA. Very simple. I'll not be asking any like serious questions. It will be very very simple questions. DNA and RNA. Okay. So earlier, ocean was rich in building blocks, which was necessary for replicating molecules, particularly RNA and DNA. So we have to actually bring them together to make very very long strands. But there is a problem. So phosphate is very very essential for actually building this DNA. I am showing only DNA, similarly to RNA. Building this DNA, the problem is phosphate molecules don't like each other. They don't want to come closer. Okay, they repel each other. So then how do we build building blocks, long chains of them? It was found that these, even though they repel each other, but in saline water, wherever there is a salinity, saline water, this repulsive nature goes off. So they will become affine. They can come closer and closer and closer. So when two phosphate molecules comes closer, they form a bond, and again another one. So this replication continues. So that's how DNA and RNA chains may form in the sea. Okay, so these are the building blocks, and so you are preparing the building blocks. How exactly, who is going to come and actually put life into that, we don't know, but we are prepared for that. And after some time, you take say 1 liter of water, and all the phosphate in that one has come together. It has formed a chain, long chain. The problem now is, after that what? So that phosphate is exhausted. How do we actually bring in phosphate from other places? That's where the tides comes in. So this, because of the tides, this water gets getting mixed up. So whenever phosphate from this place is exhausted, the other water will come and mix it. So at that time, the phosphate from the other side will come. So in this way, this chain can keep on growing. This is one way. And you might have read in high school or college that because of tides, whenever there is a tide, so water will come onto the ground. When the tide recedes, some water will be left out, and it will form puddles. So in these puddles, when it starts drying up, the salinity increases more. So there the chances of growing longer and longer chains will be much more compared to any other place. And also you have read that life originated on sea, and because of these tides, by mistake it came onto the ground. When it could not go back, it lost its fins and everything, and then it started growing on this one. So these things. So in that way also, tides are very much essential. That means that without moon, life wouldn't have come into picture at all. And then, so I told about receding tides. Next. Fine. At some point, life came into existence because of moon, but now it's done. Life is there in lot of varieties. As I mentioned, 8.7 million varieties are left on the earth. Why do we need earth now? Why do we need moon now? Do we need moon now also, other than for our mothers to show the moon? Okay, so let's see. You know that our earth is tilted, right? At what angle? 23.5 degrees. Okay, it is tilted. Thanks to this tilt, we have seasons. Okay, what's the problem? So if it's not tilted, if it's tilted in some other way, what would have happened? Nothing can happen, right? For some reason, assume that the angle of tilt, instead of 23 degrees, assume it has become 90 degrees. So that means that one portion will be always looking at the sun, another portion will always be looking away from the sun. I'll just take the example of Mercury. In the afternoon, in the morning, I gave a talk, so that's why I am taking an example from there. Mercury has very, very slow rotation. Its 1 day is equal to 58 days of Earth. Because of this slow rotation, the day side will be very, very hot, 800 degrees. The night side will be very, very cold, minus 200 degrees centigrade. So imagine Earth exactly becoming like this. Then this side will be permanently day, and this side will be permanently night. So this will be very, very hot. It may exceed 1000 Kelvin. This may go below minus 200. So then the entire life on Earth would have vanished. Not only seasons, entire life would have vanished. So what it has to do with moon? Moon acts like a shepherd. Because of its gravity, it is keeping this in check. Whatever the inclination, it is not more than plus or minus 1 degree away from its current value. So the moon is keeping this inclination in check. If not, if it had gone to 0, then it would have become no seasons at all. If it had become 90, then life would have completely vanished. So moon is essential, right? Then tides keeps temperature under control. How? You might have seen the movie Finding Nemo. Have you seen the movie Finding Nemo? I love to use movie names. In that one, the turtles will be moving in one particular stream. What is that stream? You don't recall the movie Finding Nemo? He goes to Australia riding a turtle, and the turtles will be taking the Gulf Stream. So what is happening is, from the hot place, the water will be moving to a cooler place, and so the temperature is maintained in the sea also. Otherwise, it will be very hot in certain places and very cold in certain places. So sea is helping temperature also under control. Not only in seawater, even on ground, because of this moon, the temperature is maintained. Okay. So how? Just now I talked about tides. Tides will be almost like 1.6 meters high. But not only that, sea, even the Earth actually gets affected. So what is happening is, it is actually increasing in size towards moon and reducing in size. It's not very high. Maybe I'm wrong. It's not 35 centimeters. It's 35 mm. Very small. But this small increase and decrease can actually make it push Earth doing that kind of work done, that is released in form of energy. So that is in form of heat. So hence, some of the places, for example, New York would have been at least 10 to 20 degrees below whatever its current temperature if these tides were not there. So in that way, moon is helping us save that also. Anyway, you know about tectonic plates, volcanoes, etc. Okay. So then tectonic movement also helped one more way because of moon. The Earth, Venus and Earth, both of them are called as sisters because they have almost similar properties, except that Venus is at a very high temperature, 273, more than 400 Kelvin, sorry, more than 400 degrees centigrade, and it has a lot of carbon dioxide, 90 times more than our atmosphere. And Earth also formed from the similar environment. How come Earth is so bearable here? And how did Venus became like that? The main reason is existence of carbon dioxide, excess carbon dioxide. But Earth also had carbon dioxide. What happened? When tectonic movements were there in the beginning, whenever there was a movement of this one, when you see in the movies now, there is a break in the Earth. When it was closing down, it actually gulped a lot of carbon dioxide. In that, and also in addition to that, lot of carbon dioxide was taken out by sea because of tides. Again, if it was very stagnant, very stationary, so carbon dioxide would have interacted only in the top layer. But because of the tides, it could actually absorb more and more carbon dioxide. This carbon dioxide was pushed into all the seashells and everything. In that way, 90% of the carbon dioxide from Earth's atmosphere was taken out. And carbon dioxide, you are very well aware of, is the main reason for greenhouse effect. So luckily, we saved ourselves from the fate of Venus because of tectonic movements again. So in this way, moon is actually helping us a lot. Do we want it or not? Do we want that to be there or not? So what happens if suddenly moon vanishes? Next. Okay, this is another thing. Best way to detect habitability or existence of life, because we can't go there and study each and every molecule, is to look for very high ratio moon or a planet. If we can detect a planet which has a 1/3 of a moon, the chances of seeing life is very high there by looking at all these things. Next. So now, assume that moon suddenly vanishes today because somebody said that I don't want you. Get away. And I'm not talking about breaking. If it breaks, some of the pieces comes and hits, it's going to be a massacre. I'll assume that it suddenly goes off. Okay, like in that Jim Carrey movie. What is that movie? He pulls it in closer. Okay, when he becomes a god himself. Now, go next one. Some of the animals, not some, many animals depend on moon for their timekeeping. So one of these examples is dung beetles. This is a sea creature. They actually stay very close to the on the beach only. They cannot live very far off from the water because their skin is so, what should I say, thin and others. Okay. So if it is actually left in the sun for longer time, they will die off. They have to be very close to water. So the way tides helps them is to track the tides. They have to track the tides. Otherwise, they might left far from the water and they might die. And they are helped only by moon, presence of moon. And dung beetles, they keep track of direction and everything using moon only. That also the polarization signature of moonlight. So they took some dung beetles in the laboratory, put enough light, but they could not find their burrow. So they just started going round and round and round, and they showed that moon is very, very essential for that. These are just two examples. Okay, I already talked about this stable axis and tectonic moment. And now I told that the tides can be as big as 1.6 meters. So imagine half of the sea in the tides. Suddenly when the moon vanishes, this entire water will fall back. So once this happens, there will be tsunamis. Almost 75% of the earth will be affected by these tsunamis. So that's the kind of force with which it will fall back. Okay. So 3/4 of our population will be affected by this. And in addition to that, if you have you seen the other side of moon in the pictures at least? Far side of moon. Go to the next one and we can come back. I think I have the picture. Go next. Go to next. Next. Yeah. See this picture. If somebody says that Chandravadane, please remember that they are not praising you. Okay. So this is the other side of moon. This is a face towards us, whatever we see regularly. So you can see what are these all these things. These are all asteroid hits, meteorite hits. Okay. So all these hits would have hit Earth if this shield was not there. So moon is acting like a shield in addition to Jupiter, who is taking away most of the meteorites and asteroids hits from Earth. Go back, come back. Okay, next. So because of these things, moon is very much important, right? As I told all those things. So now, next. So when first, okay. Now go to the next one. So why we know very well, almost all of us just now remember that, oh, I am seeing only this face of moon with a rabbit on it. I never saw the other face. How many of you thought like that? You raise your hand. I have never seen the other side of the moon. Picture of other side of the moon. We don't call it as dark side of the moon. We call it as far side of the moon. Okay. So how many of you thought have seen that other picture? Raise your hands. 1, 2, 3. Only 3 of you. You never thought like that, na? So then now the question you should be asking is, why we always see only one side of the moon? This we call it as tidal locking. Okay. So synchronous, this has become synchronous rotation or tidal locking. What happens is, Earth is here, moon is going like this. Now, for some reason, assume that orbital period is not equal to rotation period. So, at some point, the moon will want to run away from here. Just for clarity, I am not using a round one, I am using a length, this one, scale, pen, so that it's easy to understand. Now, as soon as it goes away, then there will be more gravitational force on this. Right? It is in the equilibrium here, it will try to pull back. If by chance, if it is left behind, then also it tries to pull it because the lowest value is here, and it will never allow it to turn like this. So after some time, this orbital period and the rotation period, they will synchronize, means they will be equal, same, they will be equal. So at that time what happens is, it can actually have same potential, gravitational potential, and hence they are synchronized, and this locking, whatever the locking is called as tidal locking. Okay, so if I am giving this talk to high school kids, I would have asked 2 kids to come here and play that holding hands go around. So that will be very easy to explain why you see only one face. Next. Okay, so our moon is special. Anybody know this? Where is this? This is in India. This is in Maharashtra. This is a asteroid hit called Lonar. Actually, there is a temple here. If anybody wants to go, they can go to the temple also. It's almost 1 kilometer in size. So this happened because of an asteroid hit some 5 to 6 million years back. I might be wrong about that time. So, but this is that. And on Mars and Venus and everywhere you see this kind of meteorite or asteroid hits continuously. And we see very rarely because most of these hits, like Earth has atmosphere, there will be a lot of weathering. So they will just get covered up. But on Moon, this won't get covered up. So much so that 60 years back, when the first alien landed on Moon, whatever the shoe print he left there, people say that even today it looks the same. So it has not fallen and it has not got covered. So what does it help us? It gives us a chance to study the entire history of all these asteroid hits because it is maintained. That diary is maintained. So you can study each and every hit, and from that we can actually look what was happening and how Moon was in that time. Okay, but this cannot happen on Earth because it's very rare to see this kind of craters. Okay, next. So now the question, since we have established that Moon is very important to us, let's understand how the Moon is made of. Okay, so some people say that Moon was made out of the tear of sun god and a lover, and in Japan also they say that it's a goddess who was made by something. And India, we know that, okay, in Karnataka, India, we clearly say that Chandrama and Surya are son of Diti, etc., etc., etc. So how much is true? Even in this one, African countries also. So there are many stories about how the Moon is born. So is it the case? Moon is born from the tear of sun, or a god simply said that you go there and be exist there? So let's see. So, but some people came back and said that no, that's the way. So George Darwin said that Moon is actually torn off from Earth. If it is torn off, you should have seen something, na? Why you are not seeing? Then Harold Urey said that no, it did not happen like that. So Moon was just wandering around, taking a walk. Earth suddenly caught him in its gravitational pull and pulled him, and then he is making it go round and round and round from eons now. So is it true? So to explain this, I can tell any story. Moon was just walking, it caught. Somebody say that no, Moon was torn off. Somebody say that no, somebody cut it and took a small bite. So, but how do you prove which one is correct? It has to explain these four things. Moon is moving away at the rate of 3.8 centimeters every year. It is going away from us. That shows that something, it is actually moving away, means it's a centrifugal force.
Recession of the Moon.
Yes, sir. So if we have to explain that, when we are talking about formation, we have to explain that. And Moon has a lower density than Earth. If we take Earth, around 1.4 is the norm, this one average density. It is much less than that. And Moon rocks do not have any water in them. And finally, Moon is as old as Earth. So we have to explain all the four with any story, whatever we say, without actually bringing more excuses. Next. With this, there are mainly 3 or 4 theories. One of them is a capture. As I told you, Moon formed independently somewhere, and it was gravitationally bound to Earth by after capturing. So then some people say that a chunk of Earth was flung out of the equatorial region to form Moon. Some people say that the way when Earth was getting formed around the Sun, a smaller chunk was left out, Ganesh Jyote Gauri free. So that also became Moon. Okay. So impact. Some people even say that Earth was impacted by another small body. So this impact broke it up and one piece became Moon. Currently, next. So these are the different ways. So this is how centrifugal force, because of the centrifugal force, a portion of that came out and became this one. Next. Currently, the expected or more accepted idea is impact theory. Go. So a small planet smaller than Mars or size of Mercury came and hit Earth. I don't know why the sound is not coming. My problem. Okay, so then entire Earth got melted. Two chunks of that just came out, and then one of them formed Moon. The other left out is current existing Earth. Okay. Okay. What time you usually people start from home for college? Generally, 8 o'clock, 9 o'clock, 8 o'clock. So what's the time now? 4:45. It's almost like 8.5 hours. This entire process took less than that, 7.5 hours. From the hit to formation of Earth and Moon took only 7.5 hours. So how do we find out whether this is true or not? Next. So Thomas Harriot actually pointed how exactly the different phases looks and everything, and Galileo also marked to see how different phases looks. So this is the starting of studying of Moon scientifically. Next. So lot of material were brought back from Moon. Apollo brought back almost 382 kgs. Changi brought almost 1.7 kg. ISRO is planning to bring back 5 kgs maybe in a couple of years now from now. So the study of these things have given all that information to showing that it is actually no water is there in the rocks. It is a very old. All those things they are solving. So they are actually more inclined to accepting that impact theory. So something came and hit Moon, and then they were separated out. Next. So okay, this magnet we can just skip this. So these are some of the photos by Chandrayaan-1 taken to make sure that wherever we are going to land is good enough for the landing, safe for landing. Some of these rocks are almost a few tens of meters high. So we don't want our spacecraft to land such that like this and fall down. Okay, so these are some of the pictures taken from Chandrayaan-2 and other places. Next. By the way, Chandrayaan-2 is still working and completing 5 years and giving one of the best images in the whole world. Even NASA cannot actually beat us. So that's one of the best thing. And with the TMC, we actually reached Moon in with Chandrayaan-1 itself. But that was not a soft landing. It was very hard landing. We just went and hit. Actual soft landing we did recently. Next. So let's come back to our missions now, because we now know that we have established that it is necessary to study Moon, and there are a lot of wealth in studying Moon. So we started Chandrayaan-1. Next. So what is the best result from Chandrayaan-1? Do any of you remember? Water, existence of water on Moon in the form of ice. We have to carry only wine from here. Okay. So hydration of the Moon, this is not just important for us. You know, when was in that photo I showed you in the first photo, when did that happen? In 1970s or 60s? 1960s. After that, America almost stopped their Moon mission. From past 50 years, America never thought of going back. Even though they landed a person on Moon, 70 or 60 years back, but they stopped it suddenly. And now suddenly they started Artemis, and before that LCROSS. So many things suddenly they restarted. You know what's the reason? The reason is Chandrayaan-1's discovery of water on moon. So we can say that Chandrayaan, India's moon mission, actually reinvigorated the entire lunar program of America. So we are actually so proud of that. Next. So not only in water on the surface, even in the space atmosphere also we have seen water. Next. And not exactly water alone, or many elements like sodium and other elements are also there through the moon. We could easily map. And why we are doing this? This will help us if tomorrow, if we want to actually go and stay on moon, what are the how we can actually make it beneficial. Okay, so by mining and what to mine and everything, we can actually do this by with elemental mapping. Next. And this is again the water and impact probe. When the impact probe fell there, and we were actually taking the spectra from the top, and we could actually see till what depth water was there. And these are some buried lava tubes and everything. These are the pictures from Chandrayaan-2. This is just to show how good our imaging compared to any other lunar program till now. Go next. Next. Okay, so this is the first picture where Neil Armstrong and other two. Who is the second one? Buzz Aldrin. So you know the specialty of Buzz Aldrin? He is 93 years now. He just got married 3 months back. Next. See, if you go directly to the answer to that line, you will not get all this information. Okay, so this is Edwin Buzz Aldrin, who is standing in front of Eagle module. Why I am showing this? Next one. This is the picture of Eagle module taken with Chandrayaan-2. Can you see here? It's shadow and Eagle module. This Eagle module, we have taken the picture. We have the picture of Chandrayaan-3 also landing there. Next. So this is taken with again Chandrayaan-2. The buggy movement. These people, whoever went to America, this one moon, they used a small vehicle, something similar to a beach car. So to move around. So the tracks made by that is taken by pictures, our imaging. So yeah, go. So we use what is called as LVM3. GSLV Mark 3 is renamed as LVM, Launch Vehicle Module. So Mark 3, go to the next one. On 14 July, we started towards moon. Next. It was a very, very important mission for us. And using this technique of actually going around, getting more and more energy here, we could save a lot of fuel. With the lesser fuel, we could reach moon. Good. So this is a very proud moment. This is a picture of our lander module. Okay, this is actually the lander module. This is the propulsion module. So after when we reach, this is again artist impression only. Okay, next. Science objectives, I don't have to actually tell you, people are aware of that. Go. So what we have, I don't know, I have hidden this, but even then it's not visible. Go to the next one. Sorry for this. Okay. So can we make a permanent settlement on the moon? So people have grown certain plants there, and the idea is to actually see or make moon habitable, because you have water, you might get oxygen also. So by actually growing, you can actually settle there. So Artemis is trying to establish a habitable place on moon. And another main focus of Artemis program is to put first woman on moon. Okay, India is also part of Artemis. They have just signed Artemis Accord. Next. Okay, so not only beautiful, we might actually use it for mining or orbiting space base. You can even take it use it for space tourism. These are all money making and permanent settlement. And you can even actually use it as a base for launching something else, because it has 1/3 the mass. That means 1/3 the gravity. It is easy to launch from there compared to Earth. So these are all the major things. Next, why we are doing. So next. How come I put it next? Okay, So this is, it always gives an immense pleasure. I don't know how many of you actually watched the landing on that day. So when we were getting closer and closer, at some point, the velocity instead of falling started slightly increasing. Almost all our heartbeat actually went up a notch. And I till now, I till today, I do my this one. If I was wearing any smartwatch, I could have actually used it for my whole life, how my heartbeat kept on varying with each second. Okay. So it, from here to here, it gives us an immense pleasure or satisfaction to reaching there. So our Prime Minister called this place as Shiva Shakti next. And a little bit away from that, we have a rock. We fondly call it as Nandi. Thank you very much.
Do you have any questions? You can ask.
Yes, sir. Huh? They are all future minings. For example, when we actually started Chandrayaan, one of the basic reason why we gave to government is mining of helium-3, so which can be used as fuel. So that mining may come in future.
So over a period of time, for sure,
Depends on how do you say. Maybe tomorrow, if we destroy Earth, that may be only savior. Sir, you wanted to ask him?
Maybe full moon day, we are going to see more than half of, more than 50% of the visible surface of the moon. That is the earth side moon. Why it is so?
It is a, okay. I try to answer that in a different way. So when in the early morning, so when the sun rises at 6 o'clock, we will start seeing light even at 5:30 itself. This is because of the bending. Okay, so we can use a similar thing to explain why we see little more than 50% because of bending of light or bending, whatever the bending effect.
Is it due to the fact that what is a particular term like vibration of the moon, just like sideways, no? Is it due to that?
I don't know, sir. To be frank, I am not a lunar scientist. So I don't know that. I'm not a lunar scientist. I'm basically an astronomer. Sorry. Yeah. No questions from the students?
Coloring the moon, when it will come? Colonization of
For colonization, one of the major things you have to make sure that the dependency on Earth will be minimal. See, for example, a person, a normal human being, requires 3 to 4 liters of water every day just to survive. So if you have to put, say, 100 people there, then it has to like 300 to 400 liters of water every day you have to supply. For lifting 1 gram, on an average, you spend, just to low Earth orbit, you spend 10,000 rupees. Now, to moon, it might be 10 times more. So imagine how much money you'll be spending just for water. Not only water, then comes oxygen, then comes many other things. So actually, servicing from Earth will not be a like continuously for a very long time is not sustainable. So by the time you reach or you develop technology good enough to lessen the dependency on Earth, that's the day from when habitability will start.
they have got the escape velocity for the Earth. So for the Earth is concerned, they got the escape velocity. And what is that escape velocity so far as moon is concerned?
It's almost 1/3, 7.7 to 7 kilometers plus 7 plus kilometers per Earth.
Have experienced those things.
So that's a very easy to understand. When they were actually walking, they were literally jumping. So that clearly shows that the gravity is very, very, not very low, it's low. Yes, sir.